we're going to be doing topic 4. To help you through topic 4, it'll be helpful to have a unit circle completed. So let's get that unit circle done you picked up on the way in. Go ahead and fill out all measures there. Okay? I would like you to make sure you copy down here the complete solution of a trig equation. The definition for the complete solution of a trig equation, an expression for all possible real solutions to the equation. That'll make more sense as we start going through these here in a minute. Let's move on there. I want you to now take a look at questions 4 and 5 on page 614. Answer those two questions. Okay? Questions 4 and 5 off page 614. Question 4. Show angles 30, 150, 390, and 510 in standard position on the unit circle for each angle. What is the y coordinate? So if this is my unit circle, you guys have yours that you drew on the way in, but if I'm going from theta, or from standard position up theta, in this case theta is 30, at a 30-degree angle from theta, I have coordinates. Now my x-coordinate is my cosine coordinate, my y-coordinate is my sine coordinate. At 30 degrees, y is 1/2, and that's what they're asking for there. Okay, so that's our sine. So another way to think about it is sine of 30 equals 1/2. Okay, in fact, if you did that on your calculator, which is what number 5 asks, you'd find out sine 30, they give you 0.5, but we know that as 1/2. Okay, so the sine value of 30 is 1/2. Now, if I move on to 150 degrees, which I keep going around the unit circle here from standard position to right there. Another way to think about it is if you're at 180, if you go back 30, you're at 150. So it's the same line here. You're on the same y-axis, or excuse me, the same y line here. Okay? So in this case, the sine of 150 is also 1/2. So sine of 150 is 0.5 or 1/2 as well. If you're at 30 degrees, when is the next time you would hit 1/2? You'd have to go around how much? Another 360 degrees, right? And if I'm at 150 degrees, how far am I going to have to move before I hit 1/2? Well, I'd hit it right there, but then if I go 360, I'd hit it again.
510.
Okay, so in this case we have 390 and 510. Sine of 390 is 1/2 or 0.5. Sine of 510 is also 0.5. In fact, how many times, if I'm rotating around the unit circle, would I hit 1/2?
Like a full revolution.
2 times.
I hit it twice every revolution. So when do I stop revolving around the unit circle? When you're dealing with periodic data, when do you stop?
Never.
Never. It's periodic. You keep going on. So in other words, if I was trying to find the solution for sine of theta equaling 1/2, when does sine theta equal 1/2? That's really what you just did there. How many solutions are there?
Infinite.
Well, from 0 to 360, there's 2. But if I just say, when does sine theta equal 1/2? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When do I end?
You don't.
You don't. You have an infinite number of solutions. So if you get this problem on a test and they say list all the solutions, it's a bummer for you, man, because now you are in the never-ending test world. Okay? That's like some of your best, like your best dream. You're like, yeah. And then some of you are like, that's a nightmare. Okay? So the goal today is for us to figure out a way to write that so that you can finish the dream and keep the dream, the lovely math dream alive, I guess. Okay, let's take a look at another one here. Let's look at this. This was not on there, but this is cosine. If I'm dealing with cosine works the same way. If I'm going 60 degrees, at a 60-degree angle, so when does cosine theta, okay, in this case we're saying it's 60, what is the value of cosine at 60, or our x value?
1/2.
Also 1/2. Okay? You'll notice there, if I keep going around until I get 60 degrees from 360 from standard position, I'm now at 300. So from standard out to here is 300. The cosine of 300 degrees is also
1/2.
1/2. So really right here, we found two solutions when cosine theta equals 1/2. When's the next solution where cosine theta would equal 1/2? We have 60, we have 300, 420. So we'd have to add another 360 to 60, right? So that would be 420. And then if we add 360 to 300, we get 660. And we can keep going, right? We add 360 to here. Knock it off. Hey, whatever knucklehead's back there by the door, unbelievable. That's ridiculous. Hey, so we keep going, right? Don't let that distract you. Ridiculous. Okay? Now you're with me so far. Our goal, once again today, is to find a shortcut way to write that. So, that being said, I want you to try number 6 and 7. Best you can. Here you go. So, if we're taking a look at this, when does cosine equal negative 1/2? Can I borrow your unit circle?
Yeah.
Is it done? Thanks. Alright. So, negative 1/2 looks like at
120.
Move it, we can't see anything. There we go.
And 240.
120 and
240.
240. Okay, so right there and right there. Okay, so we have, thank you, at 120 degrees and at 240 degrees. When's the next time it equal 1/2? Or negative 1/2? It equal 360 from here, right? So the way we write that is plus, yep, n times 360. N stands for the number of revolutions.
That's cool.
Okay,
I did plus 360x.
360x, that would work. Yeah. So I'm going to write this plus n times 360.
So that is the way you write it.
Yep, that's the way we write it. Those are our answers. Now we're done. Now you can keep the dream of loving math alive. Yeah, it is
How about
awesome.
loving math 10? No. No.
We don't do that.
No.
Okay?
That's not loud.
Now you think you got it? Okay, how about 7? When does sine cos minus cos equal 0?
When sine equals 1.
It'd be nice if it just said cos equals 0, right? Natasha?
One could be 0 plus n times 360.
Could be. How about this? Let's factor this. What can we take out of both terms?
Cosine.
Cosine. Cos times sine
Theta.
minus 1. Yeah, sine theta.
Would be cos
And cos theta.
Okay.
Okay, cos theta times sine theta minus 1 equals 0. Now, if you remember back to when we did factoring earlier in the year, the zero product property, all that the cool words we used, okay, whenever we were multiplying two things together to make 0, which is what we're doing here, you set each of them equal to 0. One has to be 0. So if cos theta equals 0, where does cosine theta equal 0?
90 and 270.
90. Good. And 270. You go plus n times 360. Plus n times 360. Okay, so there's two of our answers. And then, when does sine theta minus 1 equals 0? Well, we have to get sine theta by itself first. So we have to add 1. So sine theta is equal to, we add 1 to both sides.
And that's 90 and 270.
And that happens at 90. Doesn't happen at 270. That's negative. Okay, so this one just happens at 90. Do we have to write that answer twice? It already happened here.
No.
No, same thing. Those are our answers.
Should we have this one? McCoy 2?
No.
Square.
Any questions there? Elise?
Once you solve it, you couldn't like add cosine theta, take sine, then divide by cosine theta?
No, and that's a good question. That came up last period too. If you add cosine to both sides and then you divide by cosine, then you get sine equals 0.
Yeah, because then you don't get the T70.
Yep.
No, it could be cosine over cosine.
You get,
1.
It would be 1.
you get sine equals 1.
Yeah.
So you would lose this answer right here.
Yeah.
No, you'd lose this answer, excuse me.
T70.
Yeah. So yeah, you would eliminate one of your functions by doing that. We don't want to do that. Okay, so factor it out instead. Rocky.
Why do you have to set them equal to 0? Like, why do you have to set each like part equal?
Because if you're multiplying this by this to make 0, the only way you can multiply two things together to get a 0 is if one of those two things is a 0. So so you're setting this part equal to 0 and solve, and then that part equal to 0 and solve. Okay? That'll give you all your solutions. Kind of like we did with quadratics. Other questions? Okay, how many think you got it? All right. So, your assignment, if you take a look at it, you're going to skip problem 21 just because I don't like the spring bouncy thing they do. Okay? You're going to do 1 through 13, though, right now, and then here in about 5 minutes, I'm going to come up and say, hey, are there any questions? And then you're going to give me your questions. We'll go through maybe one or two, usually at least one of them. And then we'll go through an example like number 14, okay, which will help you out as well. Before you begin your assignment, tell your neighbor what sine and cosine always has to... Tell your neighbor what sine and cosine can never be greater than. Never be bigger than 1. Never be smaller than -1, right? Because if you think of your unit circle, your vector there is 1 unit. Even if the vector is greater than 1, sine and cosine will never be bigger than 1. So if you get an equation like this today,
They're absolutely
sine theta equals 7/4, sine can never be bigger than 1. What do we call that?
undefined.
Undefined, or no solution. It's not possible. 7/4 greater than 1. Okay, now tangent can be, but sine and cosine cannot be. All right, here you go. Any questions? 1 through 13. Go ahead, Rocky. Yep, number 7. Number 7, this should be a plus. Right, when we copied it out of the textbook, sorry, that's tough to see. Copied it out of the textbook, we obviously had some issues there. Someone had written a minus sign in there, but that should be a positive. And so in this case, if you look at it, sine squared theta minus 1, and we have positive cos squared theta, well, let's... We can substitute something in for cos squared theta, right? What does that equal?
Sine.
All right, let's think of it. Let me kind of slide this over, and
Sine squared theta.
we know sine squared theta plus cos squared theta. This is one of our identities, equals 1.
Could be 1 minus sine squared theta.
What does cos squared theta equal?
1 minus sine theta.
Good. Cos squared theta, that's supposed to be a theta, is equal to 1 minus sine squared theta. All right? So I could substitute that in right here. 1 minus sine squared theta. And that's equal to sine squared theta minus 1. Because from there, you should be able to solve for sine squared theta. Oh, yeah. It's true. Hi.
Are we going to have a unit circle filled out for something this tomorrow?
Are you going to have, no, you're not going to have a unit circle filled out for you. Yes?
So why wouldn't you make the sine squared theta minus 1 negative cosine squared theta?
Well, let's solve through this one first. Let's everyone go ahead and solve that real quick, okay? Okay, we should get that. Sine squared theta is equal to 1, which means sine theta, when you take the root, remember you got to impose plus minus. All right, take the root of both sides, from sine squared to You take the square root of this, square root of that side. You get sine is equal to plus minus 1, which is at 90 and 270. Plus n times 360. Okay? And so Lisa's question, valid question, she said, why didn't, like to begin with, why didn't we replace sine squared minus 1 with negative cos? Which is what you're asking, right? So you could have, in fact, if you look at my work up there, that's what I did. So you could have went either way. You could have started with, saying, hey, this piece is negative cos squared theta equals cos squared theta. Okay? And from there, that's 0 equals 2 cos squared theta. Which means cos squared, you divide both sides by 2, is equal to 0. And cos, then, is equal to 0. And cosine equals 0 at 90 and 270. So you get the same answers. Doesn't matter which way you do it. Some of you may get hung up on, you're like, how can negative cos squared equal positive cos squared? Well, if you think of your sine curve, that we actually get to that identity in topic 5. But this isn't negative cos equals positive cos. Okay? You start thinking, try to locate both, like put some values in for theta and locate them on your sine curve, and you'll find that if you give like positive 30 and negative 30, you put those in, you're going to get the same value. Okay? All right. Yeah.
On like for example, question number 1C. It gives us a negative angle to begin with. When we're writing all possible solutions, can we say like negative 30 plus n times 360, or would you rather us convert it into the?
Yeah, go to the positive.
Go to the positive in between 0 and 360.
Yep.
Okay.
Yeah, use the positive angle measures. Okay, I want to look at number 14 real quick. Number 14 says find or solve each trig function for theta. So number 14, we need to get theta by itself. So y equals 2 sine theta. It's the first thing I do.
Divide by 2.
Good, divide by 2. Y over 2 is equal to sine theta. How do I get rid of sine?
Inverse of sine.
1 minus cosine.
You do inverse of sine. Inverse sine. Remember, that gets rid of it. If I'm looking for an angle measure. When you're looking for an angle measure, you take the inverse sine of the other side.
Can you move it up?
Yeah, thank you. You find the inverse. So when you're finding that angle, you try to find the inverse sine of the other side. That's what theta equals. So you're solving for theta.
Oh, okay. I thought you said you were trying to get an actual angle measurement or something.
Well, you'd need to know y in order to do that. Okay.
So it's